Okay, Assalamualaikum and good afternoon. Guys, boleh dengar ke suara saya?
Boleh, sir?
Okay. So today I will continue our lecture from where we have stopped last week, which is the asynchronous counter. So today we will continue with the asynchronous counter. Synchronous counter. Okay, last week asynchronous, now synchronous. Okay. So first we look into the theory part first. So synchronous counter can be designed to produce any sequence of output signals. So compared to asynchronous, okay, you can design as well, but you might be having output problems lah. But for synchronous, there will be no problem. Whatever sequence yang you nak, you boleh design. You can design any sequence that you are required to design using synchronous counter. Okay, so obviously synchronous counter is better than asynchronous lah. But of course, the design steps are more complicated compared to asynchronous. Where asynchronous we can only we can do our what we call it, congak-congak aja kan, kita dah boleh design. But for synchronous, no, you have to design their respective steps lah. Okay, and then the clock inputs of all stages, which is the all flip-flops of the counter, are connected together and so receive clock pulses at exactly the same time, and this is why they are called synchronous. Okay, so if you have 3 flip-flops for your counter, meaning that all of the clock source are coming from the same source. 4 flip-flops, then sama juga, source yang sama. Logic gates are used to generate the appropriate signals at the data input of each stage. So that is why we need the truth table, we need the K-maps. Okay, sebab kita akan guna logic gates. Whereas in asynchronous, we only use NAND gate sahaja. Okay. So the steps of designing, it is basically lebih kurang macam asynchronous, cuma dia ada dia punya spesifik lah. First, you have to identify the number of states and determine the number of flip-flops to be used. Okay, and then you produce the state diagram. How to determine the number of states? Tengoklah mode berapa, dia kira dari berapa sampai berapa, then you can get the number of states. And then how many flip-flops are used? You use the square root of modulus number. Then we produce the state diagram, and then we translate the state diagram into state table. And then from state table, simplify the expression using K-map or Boolean algebra. So basically, I will request the student to use K-maps. Once you obtain the simplified Boolean expression, and then you can draw the logic diagram. Alright, so that are the steps. First, identify how many flip-flops are used, how many states, and then you draw the state diagram. Number 2, design the state table. Number 3, use K-maps. Number 4, simplify to obtain the Boolean algebra, Boolean expression. Step 5, to draw. So ada 5 steps lah basically. Alright, so I'm showing an example here to design a mode 5 synchronous up counter. So mode 5, you have 5 states. When you start from 0, it will end at 4 lah. Okay, starts from 0, it will end at 4. So 1, 2, 3, 4, 5. So ada 5 state. 0, 1, 2, 3, 4, back to 0. So if you are able to draw this diagram, then you'll get the marks for the diagram lah. Normally diagram markah dia dalam 3 markah kalau saya tak silap lah for your final exam. Okay, and then you translate the state diagram to become state table. Okay, so the state table, you have these 3 main column lah. First one, you'll be having the present state. Then next one is the next state. And then last one is the JK input condition. So JK flip-flop input condition. So you have to have this. Alright. Now we know that there are 5 states because it is a modulus 5 counter. So the greatest number to be displayed is 4. So 4 in binary is 100, meaning that you will be using 3 flip-flops. Or you can use square root of 5, you will get 2 point something something lah, 2.0 or 2.1, something like that. So meaning that the number of flip-flop needed is 3. Okay, sebab kita akan dapat nombor perpuluhan most of the numbers kecuali yang punca kuasa 2, yang kuasa 2 punya number, when we square root them, we will get them in point, in forms of fractional number lah, nombor perpuluhan. But to make sure that you know how many flip-flops to be used is you get the a greater number which are a greater round number lah, a greater round number than the square root value. So kalau you dapat 2.1, maksudnya nombor bulat yang terdekat yang lagi besar adalah 3. Kalau 3.7, so 4. Macam itulah. Okay. Now we know that this is a 3-bit counter lah, but it is not a full cycle counter because it only counts until 4. So when you have 3 bits, that's why I stated here as CBA. Or kalau you nak guna ABC pun boleh. But that is your references lah, your preferences, sorry. You nak pakai ABC boleh, you nak pakai CBA boleh, you nak pakai XYZ boleh. ZXY pun, ZYX pun boleh. But make sure once you use ABC, then the rest of the truth table, the K maps pun you kena guna ABC jugalah susunan dia. So I'm using CBA. So meaning that for the K map also I'll be using CBA, and then the drawing as well I'll be using CBA. Okay, so don't worry kalau you guna ABC tak ada masalah, tak akan jadi salah as long as you punya ni. Okay, this is C, kalau ini ABC, so this is A, this is B, this is C. For mine, this is CBA lah because I'm using CBA. So C will be the MSB, A will become the LSB. Okay, so this is present state. Then it is going to the next state. Next state also CBA, where this is where you will list down what is the next state of the present state. Okay, so we start from 000 because it is a 3-bit, sebab 4 adalah 100, so kita lengkapkan sampai 7 lah. So 000, 001, 010, 011, 100, 101, 110, and 111. Okay, so 0, 1, 2, 3, 4, 5, 6, 7. Now this next state depends on the diagram. Okay, depends on this diagram. So present state 0, 0, 0, 0. Next state dia adalah 0, next state dia adalah 1. So this will become 0, 0, 1. Okay, then 0, 0, 1. Next state dia adalah 2. So 2 adalah 0, 1, 0. 0, 1, 0 iaitu 2. Next state dia adalah 3. So it is 0, 1, 1. 3, next state dia 4, so 0, 1, 1, next state dia adalah 1, 0, 0. 4, next state dia adalah 0, so 1, 0, 0, next state dia adalah 0, 0, 0. 1, 0, 1, 5 tak ada dalam ni, so it will goes to unknown lah. Dia letak sini sebagai don't care. 5 pergi ke don't care, 6 pergi ke don't care, 7 pergi ke don't care, meaning that kita tak tahu dia pergi mana because it is only counting from 0 until 4. So that is how you obtain your next state from your present state. How? Look into your diagram. So the state diagram is also very important because if you wrongly draw this diagram, then your next state will become wrong as well. And obviously JK input pun akan jadi salah lah. Okay, so please be careful bila you lukis you punya state diagram. Okay, so this is 0, 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 0, 5 to unknown, 6 to unknown, 7 to unknown sebab dia tak ada. So that is how you obtain present state and next state. Okay, and then the JK input condition is where you need to use something called JK Excitation Table. Okay, So dia dikenali sebagai JK flip-flop excitation table. So these things you need to remember them. Okay, so alright, so I'll use this one. So this is the JK input condition excitation table. Okay, nama dia excitation table. Okay, remember that. Where if the present state is 0 and the next state is 0, J will become 0, K will become don't care. 0, 1, 1 don't care. 1, 0 don't care 1. 1, 1 don't care 0. So that is the excitation for JK input condition untuk present state dengan next state. So this is where it gets a little bit tricky. Okay, let me check my sekejap ya. I'll get the PDF which sorry, the Excel file so that it's easy for me to it will be easier for me to show them to you lah, so that you won't get confused. So what is the example just now? Mode 5 up counter, synchronous, JK, mode 5 up counter. So basically this is the okay. So this is the solution lah, the one that I've shared with you in the notes. Okay. Okay. By the way, I forgot to tell you. These notes I have already updated a little bit on this synchronous part lah. So I have already uploaded into the VLE for your references. Okay, sebab kalau dalam notes yang lama, first kali dia tunjuk yang ni. But I don't think that some of the examples yang ada dalam ni, it won't be necessary for us lah. So saya lebih tunjuk kepada yang berkaitan dengan final exam kita lah. So this is an update version you boleh download yang baru di dalam VLE. Okay, so this is the solution. So basically this is the file lah. Okay. Then you need the excitation table. Where's my excitation table? Don't have it here. Okay, so right, this is my excitation table. I'll increase them a little bit. Okay, now what are the things that you need to compare, which is the present state and next state, depends on the flip-flop. Okay, number of bit lah, MSB and LSB and everything. Okay, how do I obtain JC, KC, JB, KB and JA, KA is by comparing C with, okay, this is supposedly to be C plus, sorry saya tertinggal. This is B plus, this is A plus. Okay, so nanti you boleh ubah dekat dalam notes tu lah. So what do I need to do is I have to compare between this C and C plus to obtain these two. B and B to obtain JB, KB. A with JAKA. Sorry. Okay, so these are the things that needed to be compared. I'm comparing C with C plus, B with B plus, A with A plus to obtain JCKC, which is the maroon color, and then JBKB, which is the green color, and then the JAKA with the brown color. So example, if I'm comparing C and C plus 0, 0, so present state 0, next state 0. So 0, 0, J is 0, K is don't care. So you dapat 0 don't care. 0, 0, 0 don't care as well. 0, 0, 0 don't care. 0, 1, 0, 1 is 1 don't care. So 1 don't care. 1, 0 don't care 1. So don't care 1. 1 don't care memang tak ada. So bila pergi ke don't care, automatically the rest akan jadi don't care. So that is how you obtain them. And then we compare B and B plus. So 0, 0, 0 don't care. Okay, 0, 0, 0 don't care. 0, 1, 1 don't care. 0, 1, 1 don't care. Okay, betul. 1, 1 don't care 0. 1, 1 don't care 0. 1, 0 don't care 1. So 1, 0 don't care 1. Okay, so obviously this excitation table is very important. Okay, but if you can memorize them, then that will be better lah. Kalau you boleh hafal, lagi senang. Okay, kalau tak hafal, then you need to refer to this table. But for your final exam, obviously you kena hafal lah table. Alright, and then apa lagi? 1, 0, okay, 0, 0, 0 don't care. And then 0 don't care, tak adalah dalam ni. Bila tak ada, then automatically you letak dia sebagai don't care. And then brown, 0, 1, 1 don't care. Okay, 0, 1, 1 don't care. 1, 0, don't care 1. 1, 0, don't care 1. Okay, 0, 1, 1 don't care. 1, 0, don't care 1. 0, 0, 0 don't care. 1 don't care, don't care, don't care. So semua jadi don't care. Then you have your complete state table. So that is how you compare between the present state dengan next state. You jangan comparekan C dengan other next state. C with C plus, B with B plus, A with A plus. Whatever you get for comparing between C and C plus, dia akan jadi JCKC. B and B plus will become JBKB. A and A plus will become JAKA. Right. So then you have your state table. Present state, next state, JK input condition. So to obtain these things, you need this table. Okay, then number 3 is to use the K-maps to obtain the simplified Boolean expression. So these Boolean simplification techniques needed to be done for each of these JK, JCKC, JBKB, JAKA. So what to be placed in the K-maps? Kalau macam ni, okay, 0, 0, 0, it is 0. 0, 0, 1, it is 0. 0, 1, 0, it is 0. 0, 1, 1, it is 1. And then 1, 0, 0 adalah don't care. The rest sampai bawah pun don't care. So these are JC punya K-map punya input. Okay, so I have done them here. So saya akan ada 0, 0, 0, 1, which is 0, 0, 0, 0, 0, 0, 0, 1. And then don't care, don't care, don't care, don't care. So don't care, don't care, don't care, don't care, don't care. So macam mana you baca? Okay, macam ni kan. 0, 0, 0, CBA. So this is my CB. Yang atas ni adalah A. So 0, 0, 0 adalah 0. This one. 0, 0, 1 adalah 0, 0, 1 adalah 0 as well. 0, 1, 0, it is 0 as well. This one. And then 0, 1, 1 dia adalah 1. So 0, 1, 1 dia adalah 1. Okay, the rest semua don't care. This is 1, 0, 0 dekat sini. 1, 0, 1 dekat sini. 1, 1, 0 sini. 1, 1, 1 sini. Okay, so normally kalau dalam you punya truth table, dalam you punya K-map, this is basically 1, 2, 3, 4, 5, 6, 7. Ini kedudukan dia 0, 1, 2, 3, 4, 5, 6, 7. So 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. Macam mana you nak tahu? You bacalah nombor dia ni. 0, 0, 0, 0. 0, 0, 1, 1. Okay, so that is basically dia punya number lah. So this is 0, 0, 0, 0, 0, 1. Oh, tak boleh. Dia kena tukar setting ni untuk dia jadi apa. Just read dia punya ni je lah. You can read by the nombor dekat luar ni. 000 adalah kosong lah. So for this one. So isi dia. Okay. And then K-map yang ini boleh grupkan sebagai this group. So this is B dengan A. So A, B for JC. Okay, and then KC dongke, satu dongke. So dongke, satu dongke. Ikut susunan ni 0, 1, 2, 3, 4, 5, 6, 7. So tak ada kosong, ada satu dan the rest is don't care. So you boleh grupkan semua. When you group all of the variables yang ada dekat dalam adjacent cells ni, it becomes 1. Okay. JB 0, 1 don't care, 0 don't care. So 0, 1 don't care, 0 don't care. So obviously you boleh grupkan dia sebagai 4. Okay. Tak boleh grup besar daripada ni. Tak boleh grupkan 3, tak boleh. Okay, you boleh grupkan 1 tapi dia tak maksimum. Boleh grupkan 2, tak maksimum. 3 tak boleh, 4 boleh. 5 macam ni tak boleh. Okay, yang boleh hanyalah 1, 2, 4, 8, 16. Remember that. So this is a full column 1 untuk A. So tinggal sini hanya A sahajalah. B dengan C dia berubah daripada ni ke bawah. KB dongke 01 dongke. So dongke 01 dongke. So bila grupkan samalah. Okay, dia akan jadi the same group. So you dapat A as well. JA 1 dongke 0 dongke. So 1 dongke 0 dongke. You boleh grupkan 4 ni. Okay, so A berubah, B berubah, yang tak berubah C. Jadi 0 ke 0, so tinggal C bar. Okay, and then last one. Dongke 1, dongke. So semua sekali, tak ada kosong, you grupkan. So KA equivalent to 1. There you have your step 3 and step 4, iaitu your simplified Boolean expression. Once you have obtained this, then you boleh start drawing dia punya logic diagram. Okay, so this is where I'm using 3 flip-flops. This is okay, C, this is B, this is A. This is C, this is B, and this is A. Alright, now this is J for C, this is K for C, J for B, K for B, J for A, and K for A. Now, first things you need to realize the clock input. So this is your clock input. I am connecting with each of the, okay, saya connectkan kepada setiap input of the clock. So they are having the same clock source. Hello. Okay. Right, so clock source came from the same source for each of them 3 flip-flops. Bukan macam asynchronous, hanya LSB yang dapat, the rest akan dapat daripada previous flip-flop. Yang ini datang daripada sumber yang sama. Okay, now JC is A and B, so I'm using 2 input AND gate. Saya tarik satu Q daripada B, satu input Q daripada A. So this is A darabkan dengan B, masukkan ke JC. KC is 1, so KC I'm connecting them directly to VCC sebab VCC tu equivalent to 1. JB is A, so this is JB, saya tarik masuk daripada output QA. So tarik daripada QA ni terus masuk ke JB. KB is A as well, tarik terus ke bawah masuk ke KB. So ini adalah A, ini adalah A, ini adalah AB, ini adalah 1. Yang ini JA adalah C bar. So daripada C ambil daripada Q masuk direct ke JA. KA is 1 as well. So KA connectkan kepada VCC. Okay. So each of the output Q dengan Q ni you connect kepada 7 segment ataupun you boleh connect kepada LED. Then dia akan start count 0, 1. Okay, dia akan start count 0, 1, 2, 3, 4, back to 0. So dia akan ulang this number lah. 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Okay, so that is basically dia punya steps to draw. So you have to make sure you draw the state diagram, make sure this is correct. Then bila dah correct, translate kepada state table. Present state, ambil number yang ada. Yang tak ada, pergikan ke don't care. Next state, tengok. Lepas kosong pergi ke mana? 1. 1 pergi ke mana? 2. 2 pergi ke mana? 3. So, kosong ke 1. 1 ke 2. Once you have obtained your present state dengan next state, then you use the JK input condition to compare between C and C+, B and B+, A and A+, to obtain JCKC, JBKB, JAKA. Okay, then, apa lagi? K-maps, translatekan untuk setiap JCKC, JBKB, JAKA. Okay, masukkan dengan cara yang saya tunjuk tadi lah. Simplify, dapat simplification kat bawah ni, baru draw dia punya circuit diagram. Okay, I think I have the mode 5 up counter. Mode 5 up counter, so saya cuba untuk download dan simulatekan untuk tunjuk kepada you saya punya answer. So let me open. Download, okay, mode 5 up counter. Mode 5 ke mode 6? 0, 1, 2, 3, 4. Okay. Alright, so you will get dia punya sequence lah. 0, 1, 2, 3, 4, then back to 0. Okay, so that is how you can obtain dia punya simulation lah. Okay, so this is what you kena buat untuk setiap soalan berkaitan dengan synchronous counter. Alright. Then we move on to another example here to design a 3-bit synchronous up counter. So 3-bit means that it is a full cycle of a 3 bits, which is 0, 0, 0 until 1, 1, 1. So 0, 1, 2, 3, 4, 5, 6, 7. Right, so you can design the state table, the present state, CBA, 0, 0, 0 up until 1, 1, 1. Next state, C plus, B plus, A plus. So 0 to 1, 1 will goes to 2, 2, 3, 3 to 4, 4 to 5, okay? 5 to 6, 6 to 7, 7 to 0, 7 to 0. So you dapat dia punya next state. Okay, input condition macam saya cakap tadi, C dengan C plus compare, so 0, 0, 0 don't care, 0, 0, 0 don't care, 0, 0, 0 don't care, 0, 1, 1 don't care, 1, 1 don't care 0, 1, 1 don't care 0, 1, 1 don't care 0, 1, 0 don't care 1. Okay, so you kena compare untuk setiap satu lah. Okay, and then compare pula B dengan B plus. 0, 0, 0 don't care, 0, 1, 1 don't care, 1, 1 don't care 0, 1, 0 don't care 1. Okay, 0, 0, 0 don't care, 0, 1, 1 don't care, 1, 1 don't care 0, 1, 0 don't care 1. Okay, and then last kali A dengan A plus, 0, 1, 1 don't care, 1, 0 don't care 1, 0, 1, 1 don't care, 1, 0 don't care 1, sampai bawah sekali lah. Okay, so make sure you understand macam mana nak dapat input condition ni. First, you kena understand how to get the next state and then how to get the input condition. Okay, you compare C and C plus to obtain JCKC, B and B plus to obtain JBKB, A and A plus to obtain JAKA. Macam mana nak dapat? Guna excitation table. Boleh cari dekat dalam internet. Okay, 00 apa and so on. Okay. Once you have obtained the JC, KC, JB, KB, and JA, KA input condition, then translate into the KMap. So you will have this as your KMap output lah. So this is A and B. C berubah 0 ke 1. JKC is A and B as well, sama. JA is the whole column of A, so adalah A lah. KB also sama, A juga. JA, 1 don't care, 1 don't care, 1 don't care, so 1. KA is don't care 1, don't care 1, don't care 1, don't care 1, so 1 as well. So JC dengan KC AB, JB dengan KB A, JA 1. So you can draw them directly. This is C. Ambil satu output B, ambil satu output A, masukkan kepada JC and KC. Tarik A masuk ke JB dan KB. Tarik VCC masuk ke JA dan KA. Clock source for each of the flip-flop comes from the same source. Then setiap output ABC masukkan ke LED. Dia akan count 0, 1, 2, 3. Dia akan count yang ni lah. Sorry. Dia akan count this lah. 0, 1, 2, 3, 4, 5, 6, 7. Back to 0. Okay. Alright. So if you compare synchronous to asynchronous, synchronous tu lagi senang lah. Congak-congak je you dah boleh dapat ni circuit. This one tak boleh. You need to do all these 4 steps. State diagram, state table, KMap and simplified. Baru you boleh lukis dia punya diagram. Okay, kalau tak buat, then tak boleh lah. Okay, another example, design a mode 10 synchronous down counter. Okay, so don't get easily confused with the up dengan down ni. Okay, normally what happens bila dalam final exam, I ask the question something like this lah, mode 11 ke, mode 14 ke, down counter. So bila dia lukis, dia tersilap the direction of the arrows. Down counter means that it will count down. Dia akan kira secara menolak, bukan kira secara menambah. So 0 dia akan pergi ke 9. Kenapa 9? Sebab this is a mode 10. Mode 10 adalah counter which has 10 states. When you start from 0, it will end at 9. Okay. So 0 will goes to 9, 9 to 8, 8 to 7, to 6, to 5, to 4, to 3, to 2, to 1 and back to 0. Kalau anak panah ni terbalik, then salah lah you punya diagram. Dan obviously bila dah terbalik, bila you translate daripada present ke next state, dia akan jadi salah. Semua sekali akan jadi salah. So please read the question properly. If it is a up counter or if it is a down counter, tengok betul-betul. Up counter kiraan menaik, down counter kiraan menurun. Okay, then draw the correct diagram. Yang ini salah, habis. Then you punya diagram pun, you punya table akan jadi salah. Once your table is wrong, your KMap will be wrong, your Boolean expression will be wrong, your drawing, your diagram as well will be wrong. So be careful, okay? They are very easy steps to use, but make sure you read the question properly. Okay, so yang ni anak panah dia lawan arah jam lah, sebab saya start dari 0, dia pergi ke 9 dulu, baru pergi ke 8, pergi ke 7 and so on. Okay, then what else you have to do? You have to translate the diagram into state table. So it is a mode 10, square root of 10, you will get 3.2 something if I'm not mistaken. So 1 greater round number is 4 lah. So kita akan pakai 4 flip-flops. So I'll name them as DCBA. So that's why dekat table saya ada DCBA. Next state dia D plus, C plus, B plus, A plus. Okay. So dekat sini saya tak tulis plus, but you just add them by yourself lah. Alright. So D will be the MSB, A will become the LSB. So for this table, I would like to suggest to you, bila you arrange dia punya kedudukan ni, still arrange them secara menaik. Next state ni yang you ikut diagram. Okay, kenapa? There are two ways which you can design your state table. Okay, the first one is here lah, macam ni lah, 0, 1, 2, 3 sampai 15 ni, 0 sampai 15. Tak ada masalah. I would prefer for you to use this one. Either then, you buat sebab you tahu sekarang, dia start daripada 09. So, you start dari sini, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, dan 15, 14, 13, 12, 11, 10. So, you start daripada 9. Ataupun you start daripada 15. 15, 14, 13, 12, 11. You didn't start from 0, 0, 0. Okay. It is okay. You nak letak terbalik pun tak ada masalah. Sebab diagram dia, bentuk dia terbalik. Pengiraan dia secara menurun. Boleh je you nak letak dia secara menurun. But, bila you nak ambil nilai JD, KD sampai JAKA ni nanti, make sure you ambil pada present state yang betul lah. Why I'm saying that? This normally happens dekat sini, this is 0, 0, 0, 0. Saya start pada kosong. So, bila saya masuk kat dalam truth table, dalam K-map ni, this is my 0, 0, 0, 0. Okay. Let's say you start sini daripada 15, 1, 1, 1. Ataupun you start daripada 9, 1, 0, 0, 1. Next state dia pergi ke 8, 1, 0, 0, 0. Okay, so JD katakan you dapat 1, don't care, JD, KD. Okay, but accidentally bila you letak this input condition into your K-maps, you terletak yang ini dekat 0, 0, 0, 0. Tetapi sebenarnya dekat sini adalah 1, 1, 1, 1. So please be careful with that. Sebab tu saya suggest letak je macam biasa, susunan present state in ascending numbers, nombor meningkat lah, nombor menambah. Next state ni yang you compare berdasarkan kepada diagram ni tadi. So kita tengok example 0, next state dia adalah bukan 1. 0, next state dia adalah 9. So 0 going to 9, 1, 0, 0, 1. 1 going to 0. Okay, 1 going to 0. 2 going to 1. So 2 going to 0, 0, 0, 1. 3 going to 2. 4 going to 3. 5 going to 4. 6 going to 5. 7 going to 6. 8 going to 7. 9 going to 8. Then 10 pergi mana? Dia tak ada dalam sequence. So pergi ke unknown lah. Sampai 15 ni unknown. Okay. So present state susun macam biasa, ikut nombor menaik. Tetapi next state berdasarkan kepada diagram ni. That is my suggestion to make sure that you tak keliru bila nak masukkan JK input condition into the K-maps. Sebab K-maps ni contoh macam ni This box here, cells yang dekat tengah-tengah ni, box kotak yang pertama ni, this is for 0, 0, 0, 0. So let's say kat sini you letak 9 dulu sebab nombor paling besar 9, 1009, but you tersalah ambil. 1 ni you terletak dekat sini. So it is wrong. 1 tu sepatutnya dekat 1001. So dia sepatutnya dekat sini yang 1, bukan dekat sini. Okay. So just follow my steps to make sure that you nanti tak buang markah. Okay. Nanti dekat sini dah betul, tetapi sekali transfer data JK input ke K-map jadi salah. So rugilah. Okay, so how do I obtain JD until KA? Compare D and D for present dengan next state. So D and D plus, C and C plus, B and B plus, A and A plus. So kita tengok contoh lah Kalau kita tengok nombor 9, okay. So D1, D plus 1. So 1, 1, don't care 0. 0, 0, 0, don't care. 0, 0, 0, don't care. 1, 0, don't care 1. Okay, so you compare lah macam biasa. Macam itulah cara you compare. And then yang 10 to unknown semua ni, semua jadi don't care. Senang. Terus jadi don't care automatically. Okay, and then what else? Translate to the K-maps. So 1, 0, 0, 0, 0, 0, 0, 0. So 1, 0, 0, 0, 0, 0, 0, 0. And then don't care, 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 don't care. Okay, so for 4 variables, cara pengiraan dia lain sikit lah. So ni tadi mode 5. Okay. So I'll just use these things. This is DCBA. 0, 0, 1, 1, 1, 1, 0. So the number is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, dan 15. So ini kedudukan dia. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 8, 9, 10, 11, 12, 13, 14, 15. Kalau 3 bits tadi 0, 1, 2, 3, 4, 5, 6, 7. Okay. If you are wondering macam mana saya dapat nombor, kenapa sini 13? Ni dia ni. Baca ni. 1, 1, 0, 1. Okay. So 1, 1, 0, 1 is equivalent to 8 tambah 4 tambah 1. So 8 tambah 4, 12 tambah 1, 13. Ini kenapa 2? 0, 0, 1, 0. So 0, 0, 1, 0. Okay. So 0 tambah 0 tambah 2 tambah 0. So jadi 2. Okay. So that is why I'm urging you, bila you buat you punya table ni, so make sure you letak susunan present state dia still cara menaik. Okay. Hanya next state sahaja you tengok daripada diagram. Okay. Moment ni guys. Okay. So please be careful with this thing lah, sebab menaik dengan menurun ni normally what student tend to do when they design the state table, dia letak secara menurun. Tak salah pun sebenarnya, sebab next state dia pun akan ikut diagram, so it is correct. JK input condition pun it is still correct, but bila transfer ke sini dia masuk semborono, meaning that dia akan masuk ikut macam ni lah, 1 0 0 0 0 0 0 0, dia masuk je 1 0 0 0, dia ingat susunan dia macam tu. Padahal sepatutnya dia kena masuk daripada 9 dari sini. Apa nombor yang dekat sini lah, what are the numbers at the present state. So be careful with that. Okay. Okay, so this one you can simplify this one with this don't care. 2 saja, tak boleh 3, 4 pun tak boleh sebab keliling dia kosong. So this is D berubah, C is bar, B is bar, A is bar. So A bar, B bar, C bar for JD. KD, you can group this one as one group. So sepatutnya ni boleh group kepada 4 sini dan sini. So 1, 2, 3, 4, 5, 6, 7, 8. So saya punya solution ni ada salah sikit. Let me open the notes. Okay. Okay, so ada error sikit. Okay, this one should be, yang ini sepatutnya you groupkan dia besar lah. Boleh je. Dan something like this. Dan ini. Okay. So D dengan C dia akan berubah, B 0 ke 1, A daripada 0 ke 0. So this will be A bar only. Okay, sorry about that, ada error sikit. So please betulkanlah dekat dalam notes itu. Okay, so D and C daripada sini sampai ke 4 adjacent cells, so dia berubah. B 0 ke 1 berubah, A 0 ke 0 tak berubah, so jadi A bar. Okay, this one as well, ini pun sama. This should be like that. Okay, so 1, 2, 3, 4. 6 tak boleh, 6 tak boleh, 8 tak boleh. So this will be D tak berubah, so D, B, C berubah, B 0 ke 1, A. Okay, so this will becomes apa tadi, D, C, B, A bar dan D. 0, 0, 1, 1 potong 0, 0 dan D. Okay, so A bar and D. Okay, and then K, C, you can group this only for one group like this. Okay, tak boleh nak besarkan lagi. So it is A bar dengan B bar lah. C dengan D berubah. Okay, and then this one, 1, 2, 1, 2, 1, 2. Okay, so this is a bit complicated. Dia sebenarnya group dia macam ni lah. Okay, mula-mula yang ni 2. Lepas tu second one yang bawah ni. Yang bawah ni saya tukar color di hijau So samalah dalam diagram ni, cuma sebelum ni saya tak guna warna, so susah nak tengok. Okay, so for the red colored, D is changing, C is not changing, so ambil C. B is changing, A is A bar, so A bar C untuk merah. The green one is D dengan A bar. Okay, B, C berubah, B berubah, A tak berubah. So A bar C plus A bar D. Alright, then for KB, you can group them with 1, 2. Okay, so ada 2, 1 dan jadikan di group 8. You will get A bar. B berubah, C dengan D obviously berubahlah sebab 4 petak. JA adalah 1 dan KA adalah 1 sebab it can group all of them together. Okay, so nanti saya upload yang ni lah, latest one. Alright, so this diagram obviously akan ada error sikit lah. Nanti you please change them by yourself. Diagram ni untuk KD jadi A bar sahaja dan JC sama dengan A bar D. Okay, so kita try tengoklah. JD is A bar, B bar, C bar. So this is JD. So pull one from A bar, pull one from B bar, and then another one from C bar. So masuk ke JD. Okay. Okay. KD is A bar. So KD supposedly yang ni datang daripada A bar. So patutnya you just tarik directly daripada sini je. A bar, just pull them straight, tak payah lalu N ni, masuk ke KD. Okay. And then JC adalah A bar dengan D. So this is JC. Masuk daripada A bar. So this is A bar tadi kan. Ini buang jadi A bar. Dan satu lagi pull out daripada QD. Masuk kepada KD. JC. KC adalah A bar B bar. So KC comes from A bar dengan B bar. Okay, this one is A bar. This one is B bar. Masukkan ke KB. Okay, and then JB A bar C plus A bar D. So you need an OR gate here. Comes from here. This is C. And then this is D. Sekejap. This comes from, okay, dia datang sini from A bar. This is C dengan D. Okay, C plus D darabkan dengan, this is C plus D. N kan dengan A bar. So A bar darabkan C plus D, you akan dapat A bar C plus A bar D. Going to JB. And then KB is equivalent to A bar. So just pull one from A bar, masukkan ke KB. JA and KA, connect them together to VCC for 1. Sebab nilai dia adalah 1. Okay, then clock input comes from the same source for each of the flip-flops. So bila run, dia akan kira number apa? What is the number? 9 until 0 back to 9 again. Okay, so that is how you design them lah. Kalau you tengok memang a bit complicated lah, sebab the first one because it is a 3 bits, because it is a 4 bit, so jumlah bit dia tambah 1, and then dia punya equation pun panjang-panjang, nampak? Ada 3 bit, ada yang 2 bit tambah 2 kali and so on. So diagram dia akan jadi banyak gates lah. Okay, cuma dekat sini yang salah tu dekat K ni tadi kita ambil daripada A bar dan juga daripada apa dia kata? Okay. KD A bar dan yang ni tadi JC pun A bar dengan D, so kena guna gate lain lah. Meaning that my drawing ni ada salah sikit. Okay, so this table nanti saya dah ada new one that I have just uploaded just now. So nanti saya akan upload semula kepada e-learning lah, yang ada salah sikit tadi. Okay, so basically kalau kita tengok, yalah kalau kita tengok macam senang, tapi sebenarnya dia senang je, cuma it needs very concentration yang tinggi lah, especially bila you compare between the present state dengan next state ni. Okay, and then bila you nak extract the JK input condition ke dalam K-maps ni also you need to do them properly. Lepas tu bila you nak simplify pun, tengok macam saya tadi kan, saya terus je nak buat. Okay, so this is the K-map, saya ganti dekat dalam ni. Nanti saya upload semula ya. Ni ada saya betulkan dua ni. Yang ni okey, tak ada masalah. And then this diagram pun nanti you betulkan sendirilah. Yang ini datang daripada A bar sahaja. For for KA. KA ni datang daripada A bar. And then KD comes from A bar only. And then C comes from A bar dengan D. Bukan A bar, B bar, D. Bukan A bar, B bar, D bar. Saya dah delete tadi tu. Okay, so you boleh tukarlah tu nanti. Drawing ni senang je berdasarkan kepada you punya output yang you dapat dekat sini. Boolean expression. Okay. Then we have another example here. Yang ini dia agak simple kalau you tengok, but it has a statement here with don't care condition. So saya highlightkan dia warna merah. So what does it mean? It will becomes a counter with this sequence, dan whichever number that are not listed is this number will go to don't care. So dia akan pergi ke don't care, tak tahu. Okay, so 0 to 2, 2 to 5, 5 to 6, 6 to 1, back to 0. 0 ke 2, 2 ke 5, 5 ke 6, 6 ke 1, 1 ke 0. Okay, so bila you buat present state, starts from 0, 0, 0, 0, next state dia 2, 0, 1, 0, and then bawah ni sepatutnya ada 1, 1, 1. 1, 1, 1, sepatutnya, 0, 1, 0, sorry, 0, 0, 1. 001 sepatutnya pergi ke 000. Okey lah, macam table ni pun tengok dia terbalik kan. Dia letak 0 ke 2, 2 ke 5, 5 ke 6, 6 ke 1. So this type of table, it may confuse you bila you nak masukkan JK input ke dalam table ni later on. So I would suggest, ini saya nak tunjuk dekat you lah sebenarnya, apa dia punya complication that might happen. So bila letak sepatutnya you letak macam biasa 000, 001, 010, 011, 110 sampai 111. Whichever numbers which are not included here, dia punya next state dia jadi don't care. Contohnya nombor 3. 0 to 2, 1 to 0, 2 to 5. 3 tak ada. 3 pergi ke don't care, don't care, don't care, and then obviously semua JC sampai KA ni akan jadi don't care. 4 pun tak ada. So 4 pun jadi semua don't care. 5 ada, 6 ada, 7 tak ada. So 7 akan jadi semua don't care. Okay, then we stop at 7 only because you only have the greatest number which is 6. 6 is 110. So kita perlu hanya 3 bit. So the greatest number for 3 bits is 111 which is 7. So tak perlu buat sampai 8. Okay, so you can rearrange this table. Jangan buat macam yang ini. Yang ini dia akan mengelirukan. Lagipun nombor yang tak ada dekat dalam ni, dia tak listed down. Okay, nombor 3 tak ada, nombor 4 tak ada, nombor 7 tak ada. So that could be very dangerous. Sebab bila you nak masuk kat sini nanti you keliru. Nombor 4 nak masuk nombor apa ya? Sebenarnya 4 tu adalah don't care. Sebab dia dah bagi tahu with don't care condition. Okay, so from the state table, you will obtain these K maps. So JC is B, JB is A bar plus C, JA is B, KA is B, KB and KA is 1. Okay, so that is the Boolean expression obtained. Then JC dengan KC adalah B, so JC, KC pull directly from B to go to JC dengan KC. JB A bar plus C and 1. So JB tarik satu dari A bar, tarik satu daripada C, masuk ke JB. KB 1 masukkan ke VCC. And then JAB KA 1. So JA tarik satu daripada B, KA tarik daripada 1 which is the VCC. Clock source going to the all same input clock for each of the flip-flop. Then each A, B and C connect kepada VCC, connect kepada LED, dia akan count this number 02561, 02561 without any problem. Sekiranya diagram you betul, dia tak akan ada problem untuk display number ni. But for asynchronous, susah untuk you display nombor bersepah macam ni. Dia akan jadi error. Okay. Alright, so how many examples are there? First, kita tengok mode 5 up counter, and then 3 bits up counter, and then mode 10 down counter, and then this is mode 5 nombor berselerak, okay, segregated numbers with don't care condition. Okay, susunan dia 0 ke 2, 2 ke 5, 5 ke 6, 6 ke 1, balik kepada 0. Okay, so obviously this type of counter, you jangan buat cara yang saya tunjuk ni. You buat macam yang ini. Kedudukan dia 000 sampai 111. Okay, D tak ada lah. So dia ada CBA 000 until 111. So that you won't get confused bila nak masukkan data input condition of the JK ke dalam truth table. Kalau you salah letak, walaupun walaupun you punya simplification betul, tetapi jawapan you confirm akan jadi salah. Sebab you tak mengikut apa yang sepatutnya lah. Right? So then you have 4 examples yang saya dah tunjuk lah untuk design synchronous counter. Okay, so there are one exercise for you to try, but the first one has already been given the solution here. Okay, so it is a mode 6 synchronous up counter. So 0, 1, 2, 3, 4, 5 lah. Mode 6 ada 6 state 0 sampai 5. So present state 0, 1, 2, 3, 4, 5, 5 to 0. Lepas tu bawah ni sepatutnya ada lagi 6 dan 7. 6 dan 7 pergi ke unknown. So yang the rest ni akan jadi don't care. Okay. Compare C and C+, you dapat JCKC. B and B+, you obtain JBKB. A and A+, you will obtain JAKA. Okay. Then transfer JAKA, JBKB, JCKC ke dalam K-maps. You will get JC, AB, KC, AC bar. JB and KB both A. JA and KA both 1. So buat connection lah. JC sama dengan AB. So JC tarik satu daripada B, tarik satu daripada A, masuk ke JC. KC adalah AC bar. So KC datang dari this one. This one comes from A, and then this one comes from C bar, masuk ke KB. JA, KA adalah A. So pull A. JB, KB, sorry. JB, KB adalah A. So JB, KB datang daripada A. Okay, so this drawing is ada silap sikit. Bukan datang dari sini ya. Sebab this is ini, ini datang daripada JC dengan KC. Okay. Okay, nanti drawing ni you perbetulkan sikit lah. Tak pun saya betulkan lah dekat sini. This should comes from here. Okay, ini datang. Okay, this bubble sepatutnya dia dekat sini. Mana saya nak tarik ya? This is supposed to go here. Okay. Okay, so meaning that yang ini salah lah. Yang bawah ni you padam je. JA dengan KA datang daripada A. So sepatutnya dari sini terus masuk sini. Dan juga terus masuk sini. Okay, so sama tukar pada merah. Okay, so yang ini padam. Saya tanda sini lah pangkah. Okay, the rest ni pun pangkah. This is tak ada Okay, yang betul yang mana merah ni. So J pergi ke sini, KA pergi ke sini. And then JA, KA comes from JA, KA, JA1, KA1. So datang daripada VCC. Then that is good lah. Okay, so before that, let me change the diagram dulu lah. Okay, so ini saya betulkan on the spot lah. Okay, so nanti saya upload balik dalam you punya e-learning. Okay, ada mistake dekat sini dan juga ada mistake dekat sini tadi. Alright. Then you have the solution lah. So this is the solution for this mode 6 up counter. Alright. So question 2, design a mode 11 synchronous down counter. So tadi kita tengok dekat sini kita buat mode 10 synchronous down. Sekarang mode 11. So you can try to design them lah. Nanti saya akan share dia punya solution. Okay, mode 11 synchronous down counter. So dia akan kira 0 ke 11, 11 ke 10, 10 ke 9, turun sampai 1, 1 ke 0, 0 ke 11. So dia tak akan singgah 12, 13, 14, 15. Okay, these 4 numbers, 12, 13, 14, 15, dia akan pergi ke unknown. So JD sampai KA semua jadi don't care, unknown. Okay, so you may try to do this by yourself. Okay, nanti saya akan share dia punya solution lah. Okay, and then kita akan masuk finishing machine. This is next week lah kita akan masuk. Okay, so that is the today's lecture. So let me change the notes first. Topic 4 topic 4 ke? Oh yes. So topic 4, I'll change the file to the latest one lah yang saya ubah tadi. The file topic 4 sequential sequence. Okay, so please use the latest one. Okay, untuk mengelak kekeliruan 27203, I'll change them as well. My notes, topic 4. Yes. Okay, so saya dah ganti untuk dua-dua subjek lah. Okay, so that is for lecture 4A lah. We have already covered asynchronous dengan synchronous. Okay, so obviously you will have a lot of question. Okay, kenapa macam ni, kenapa macam ni, tak faham or anything. So should you have any question, boleh tanya. Ada ke nak tanya saya regarding hari ni punya lecture? Anybody? Tak ada. Boleh faham ke?
Boleh, sir.
Boleh okay. Very good. Kalau you boleh faham, alhamdulillah. But for sure, to make sure that you really understand, cuba buat nombor 2 ni by yourself. Okay, nanti saya akan share the solution untuk you tengok compare dengan saya punya solution betul ataupun tak. Alright. Okay, so I think that is it for today's lecture lah. Itu sahaja. And then for yesterday's group, which is LO1 BO2, I just want to confirm with you guys that our tutorials has already been changed. Ada perubahan sikit soalan tutorial. Okay, so please use the latest one, which is this one tutorial 4A. So saya dah upload dekat sini lah. Saya ada ubah dekat soalan 5 dengan 6 ni, saya ada ubah soalan dia. Okay, so please use the latest version. Jangan guna yang semalam kita buat dalam kelas. Even though until yesterday kita buat sampai question 4 sahaja. Okay, but please proceed dengan question 4 as 5 and 6. Sebab you dah belajar. Today we have already learned about synchronous. So you dah start boleh buat lah yang ni. Okay. For the rest of you, ada lagi 3 group. Kita akan bincang masa kelas esok dan hari Khamis lah. Okay. Okay, so I think that's it from me. I'll share the attendance for you guys. Okay, let me share for the 2 guys. Bukanlah LO1 Digital Electronics. Okay, for Hasnul and Daniel, please scan your attendance. Boleh ke? Ke tak ada? Hasnul tak ada, Daniel pun tak ada. Okay, so tak apa. And then LO1 Digital Electronic Principles. Okay, so guys, please scan your attendance.
You, sir.
Okay, thank you. Cuba buat ya yang dalam soalan.
Thank you, sir.
Okay. Cuma yang dalam soalan tadi ada satu soalan lagi, mode 11 down counter tu. Alright, and then the rest kita akan bincang masa tutorial lah. Okay, thank you guys. Assalamualaikum and good afternoon.
Right, sir. Thank you, sir.
Thank you, sir.
Okay. Siapa yang tak boleh scan, please let me know. Ada berapa orang ni? 20 orang. Kami dah keluar. Anyone? Ya.
Boleh tolong tikkan nama saya tak?
Boleh. Nama?
Hadi Bestari.
Adi Bestari. Okay. Anyone else?
Okay, thank you, sir.
Nama? Ada lagi? Okay, tak ada Syami, Khairul Rizwan, Imran, Afiq, Muhammad Syami Is. Afiq ada. Imran, Khairul Rizwan.
Selamat berbuka nanti, sir. Assalamualaikum.
Okay, thank you. Waalaikumsalam.
Memang perlulah dedication. Tak pandai buat kalangan.